Folks, we're going to take a look at number 2 from the intersections of lines and curves sheets. So here they're asking us to determine the point or points of intersection, if any, of the parabolas given here. So again, before we actually start on this particular example, let's see what the possibilities are. Okay, so say I have one parabola. Okay, now let's say they do cross each other. Well, see that they can cross each other at 2 points. That's certainly a possibility here. Okay, now they could also not cross each other at all. Okay, so here have no points of intersection, or it could be that the parabolas perhaps just touch at one single point. Okay, so say only one point of intersection. So yet again, we have a scenario where we've got 2, 1, or no possible solutions. So that gives us a sense that analytically, we're probably going to be solving a quadratic equation, because a quadratic equation has exactly those 3 possibilities. Okay, I don't think that'll be too surprising. So we talked last time when it was a line and a parabola that we were able to use either elimination or substitution. And here, the exact same thing can occur. So I can subtract the 2 equations in order to eliminate the y variable, or I can substitute this y variable, okay, with its equivalent expression from here, negative 3x squared minus 2x. So that's what I'll do, is all here, y is already isolated. So wherever I see y here, I'm just going to replace it with negative 3x squared minus 2x. Okay, so I'll use substitution here. So negative 3x squared minus 2x is going to be equal to x squared plus x plus 1. Okay, and not surprisingly, we have exactly what we expected, which is a quadratic equation. So now let's put it in the form we need to be able to actually solve this equation. So looks like it's negative here, so I'll bring everything to the other side to get 0 on the left. So you have x squared plus 3x squared, so 4x squared. Here I've got x plus 2x, so that's going to be plus 3x. And then here I've just got the plus 1. Okay, so again, I could try to factor, but it's not looking too promising, because even though 4 is 4 plus 1, everything's positive. I would have to subtract 4 and 1 to get 3, and everything's going to have to be positive. So we're going to use the quadratic formula. Since it's in the correct form, I can go ahead and solve it now. Okay, so negative b, so that'll be negative 3 plus or minus, okay, b squared, so 3 squared minus 4 times a, which is 4, times c, which is 1, all over 2a, which is 2 times 4. Okay, and when we calculate the value inside the square root, some of you might already be seeing that we're going to have 3 squared is 9, minus 4 times 4 is 16, and we have a negative value in the square root. Okay, so this gives us negative 3 plus or minus square root of negative 7 over 8, which indicates that there are no solutions to the equation. Okay, and what does that imply in terms of the points of intersections? That must mean that there cannot be any points of intersection. Okay, so no point of intersection. Okay, so as we've seen before, when you have a quadratic equation, one of the options is that there's no solution. Okay, so that's it for this one. Nice and easy.